This is a video where I go over how to create a landing for a spiral set of stairs. This is a question that I got from one of my students on how to create spiral stairs with the landing. I'll be going over all of the steps here from the basics all the way to creating the inside and outside railing. So thank you very much for being here, and let's jump right in. The first thing I want to start with is making sure that you are working with the same units, or at least you know what units I'm using. I'll be using inches, decimal, and if you're using millimeters, just make sure that you use the units of what you typically use for a tread. So if your tread is going to be 6 inches by 12 inches, then you'd use inches, and you do the same thing for millimeters. So when we hit OK, now we have this file, and we're going to be creating that spiral staircase with landing. So to first start, we need to create the point where this is going to be located. We're going to create it here at the 0, 0. So we'll create a point. We'll go here to construct point, and this will allow us to change the location or move it using these inputs. But I also like to route it through a point component. This way we can always change the location of where our design is going to be by setting a point, a Rhino point, and then we can change that location. So with this, we'll be starting, and this is where we'll be creating the circle, which will be where the base geometry is going to be. It's a spiral staircase that is going to be based off of the circle. So the first circle is going to be the inside diameter of the stairs. So I'll use this point as the point input for the plane. And notice that that plane icon went away, and that's because we plugged in a point to the plane. Now we'll go to a radius of 60 inches. But what happens is it's 60 inches from here to here, 60 from here to here, so it would be actually 120. And I like to use a diameter. So inside diameter. And since this is right now a radius, well, what we need to do is divide this by 2. So 60 divided, so /2. This will take 60 in A, it will create 2 for B, and now we have the result which we could use for our diameter. And so now we have 30 and 30, making it a 60 diameter on the inside. So with this, we can start our base geometry. Now we're going to offset to create the treads and the width of the stairs, and from there we can continue the rest of the design. Now let's take this circle and we're going to offset it to create the width. So we'll go to offset, curve. We'll be taking the circle into the curve input, and it's offsetting to the outside, so that's fine. And we'll type in 48 for the stair width. So between these two is where our spiral design is going to go. What we need to do is extract 2 points, one at the start here and one at the start here, so we can create the tread line that then will rotate. So what we'll do is we'll go to endpoints. This will give us the endpoints of the circle. The circle typically doesn't have an endpoint. It has a start, goes all the way around, and it ends where it starts. So it will give us actually 2 points right there, and we'll do the same thing for the offset curve. Now we know that we have start and an endpoint and a start and an endpoint. We want to make sure to create the line segment between the start point and this other start point. As you can see, it creates this line here. That is what we need for our initial tread. So this is where it starts. Then we need to create the rotation for our first tread. What we'll do is go to rotate. We want to rotate this line, so that's going to be the geometry we plug in. Then we want to rotate relative to the middle, or to the origin point, or to the center of the stairs. So this is where we could use this initial point as our plane input. And depending on what angle you want to use, I typically go to degrees. Now we can give this a value. So angle, we'll say 45. And notice that it rotates it at 45. And if you wanted to go the opposite direction, we can go negative. And create the rotation. So that's how big the tread is going to be. But what happens is we want to create an even amount of treads for this circle. So to achieve this, we need to use a calculation where we take 360 and divide it by the number of treads. So this part's a little bit confusing, but once it clicks, you'll be able to see how this works. First, we start with 360 degrees, which is for a circle. So I'll do quotation marks 360. This will give me a panel that is 360. Now we can say 360 divided by how many treads? Well, we'll say 20. So we'll go here to 20. We want 20 treads in this 360 degree circle. So we'll do a division. If we have 360 degrees and you divide it by 20, each segment is going to be 18. Now we can take this result and plug it in here, and you'll see that every time we increase the number, we actually get a smaller tread. So this is what we want to do when we create the rotation for the array, is to have these numbers in mind, because those are the numbers that we'll be using to create the array. So with this, now we have two line segments that are sitting on top of the base geometry. Now we need to create the tread surface. There are different ways we can do this. The way that I like to do it is by selecting both of these circles and creating a surface between the two. To do this, we'll go to Boundary Surfaces and plug in both the interior circle and hold down Shift and add the offset. You'll see that once you add two of these, you'll have overlapping surfaces. I'm trying to make sure that this is clean for everyone. So we have overlapping surfaces. We do not want this because we just want the hole in the middle, so we flatten the input. This brings it in as if they were both in one list, and then it will create the surface between the two. Now we'll take the rotated line segment and the straight line segment, and we'll go to a split surface or surface split using a curve. Now we can use our surface as our surface input, and our curves are going to be our initial line, and then holding down Shift, I'll add this other one. So you'll see that it split it right at these two. I can disable the preview on those two, and I can disable the preview on our original geometry. So now we can change the size of the tread. Now we have here at the outside, we have two fragments. One is going to be the leftover, and the other one is going to be the tread. So to pick one of them, we'll go to List Item. And by default, it'll pick the other side. And so you can either right click and go to reverse, or instead of doing this, you can go here down to the plus sign, add a plus sign, and then out of one, or actually we can extract the separate surfaces within these fragments. And now we can disable the preview, and we see that we have this and this. Now we don't need this one, so we can delete it. But now with this tread, we can get started creating our array for the stairs. Now here, I do have it as a negative. I do actually want it to be a positive. And when that happens, you'll see that the way that this was organized, you actually want to go to this one. So the reason why I do this is it's better to start here and go up and around, just because this is our plus sign, and we just kind of want to go this way. just understand that there are different ways that we can approach this. So with this tread, let's create the array all the way around to match the circle. So like I mentioned earlier, we have this equation, which is how many subdivisions we're creating. So what we need to do is take this and go to a rotate, because we need to take this and rotate it relative to the center point. So we'll go back to this point, which is this point. And if you don't want to go back to the beginning or the component at the start, I do sometimes create a relay a little bit closer to where I need to use it. So now I can use this point as our plain input. And now we're going to create a series of rotations. So for this, we've set the stage, but we want to create more than one number. What happens is this is only one static number of 17. I want to change that to 17 plus 17 plus 17. So you can have a range or a series of numbers. So we'll go here and create a series component. This is going to be simple because we have the stage already set. The steps is going to be the amount that it's going to step by. So 17. Count is how many treads are here. So that's going to be 21. And start, well, we're going to start at 0. Then we can use the series of numbers, making sure that our angle is also in degrees. And we can use the series output. Now, all we need is that tread. So now we'll go back here to the end. And this is why I wanted to have it out here, is because we need to use this surface as our input. So one step at a time, now we're seeing that we're able to achieve the entire rotation. This works. And get it to match the original circle. Now, if we change this, that's why we tie all the numbers. That's how many treads we're going to have going all the way around. Now, we know we want to have a landing, and that will come in shortly. But with this, we set the stage to now create the vertical array. In the same way that we rotated it around, arrayed it circularly, we can array it vertically. Also using a series component, because we want to create that many numbers, so 25. And I'll actually do this, a relay here, move this up a little bit, and use this count. That's that count. We can also copy that other component. So with this, that's going to be how many times. The step is how much vertical height we're going. So we want to say the tread height. Now we have a series of numbers starting at 0 and going to 6.5, and then 6.5 plus 6.5 is 13, and so on. Now we can move the geometry that we rotated in the Z direction, because these numbers we want to move up in the Z direction, and then we can use this vector as our motion. So it does this one by whatever the tread height is, and this one whatever the tread height is, and so on. .360 is going to be a constant because that's the degrees in a circle. The inside diameter, the width of the stairs, number of treads, tread height, now we have our set of stairs. Now for this next portion, I'm going to show you how to create that landing, because if I take this and I just copy it vertically, what happens is you don't have a landing, and if you don't have a landing, then it's technically not code compliant, and also you don't want to have a really long run of stairs without a place where you could rest. So let's go ahead and create that. All right, so to create the landing, it's a bit of a trick here, because we have these many treads, right? We have 25 treads. All of the 25 treads have a value that adds up to this one. So if we took the 25 value here and we subtracted 3 of them, that will bring the total number down, and therefore won't raise these. So this part is confusing and it may not make sense right now, but let me show you what I mean. We have 25 treads. The 25 treads go into the vertical array, but we don't want 25 treads. We want 25 minus 3. So I'll do a subtraction and then 3. This way, it doesn't bring up these last 3 treads. And technically it's 1, 2, 3, and 4, right? Because it's the last one plus the 3. So this is where we can do 3 minus 1. And this is more of a visual thing, so you know how many treads we will be using for the landing. So 3 minus 1 will be number of treads for landing. So now if I take this and I bring it up to that number, it will be a perfect set of spiral stairs with the last 3 being the landing. Hopefully that makes sense. And now I'm going to show you how to take this and move it up. So first thing we'll do is we'll give this some thickness, the same as the tread height, and we can change that. So let's do that. Let's go to extrude this geometry. In which direction? In the Z direction. By how much? The tread height. So whatever this is, that will adjust. So at this point, we can hide the treads. And now we can copy this vertically. So we'll take this, and first we actually need to get the value of how much we're moving this up by. But first we'll go here to move all of these. In which direction? Well, unit Z, because up and down. Mostly up. We want to bring this up by this much. How much is that? Well, we kind of know that here. We have 6 times 23. So if we do that, multiplication of 6 treads plus how many we have here, now we have 138. We want to move this up by 138, or whatever value that is, depending on the numbers that we pick. And once you can do this once, let me show you here. So tread height and then treads for landing. It could be as much as that if you wanted to. So with this, we have everything we need to set the stage and create the vertical array. How? Well, we have unit Z, we have motion. All we need to do is create a series of numbers that's step by I'll double click here to create a relay, step by this much, and goes up in the Z direction here. It's going to create 10 sets though. And it won't work unless you graphed the input. That's the other thing to keep in mind. Once we have this, we can pick a count. So the count is going to be how many sets. We'll just go to 3. Let's keep it low for now. We can always change that. And our originals are still here. So we have created the base geometry for a spiral set of stairs that has a landing. This is really useful for building towers and things like this. And the cool thing is that we can change how many we have. So now this is just the base geometry. I want to go over how to create a really nice seamless railing, both for the inside and outside. So that's what we'll be going over now. But the bulk of the work and really the most important part we've already gone over. This I can reshape. There's going to be number of floors. Bed height, number of floors, and everything is good. I'll disable the preview on most of this stuff down here. Bring this back down to number of floors 1. And now let's create that railing on the outside. For this next part, we need to create the railing. What we'll do is start with our initial point, and we're going to create an array the same way that we did with the treads. What we'll do is take our rotation, slide it down, tap Alt to create a copy. Now I can use the starting point as a geometry input, and we've created those points. Now we need to move them up the same way that we brought up the treads. So to do that, we'll take our rotated points, go to a move component, and we'll be moving them up vertically like we did with the treads. So when we go up here to our treads, we see that we've used this tread height, the series of numbers, and I'll use that same series of numbers to move up my points. As you can see, we have one point here that is not added. So what we can do is take one point here and we need to add it. So to do this, I want to show first that we need to add one more point. So to do that, we need to create another number for the number of rotations. So let's go back and look at this is going to be our angle. This has already been created for you. So this is if we have 25 treads, we need to add one more. So we'll do +1, 26 treads. The count is going to be less. So 25 treads, we add 1. Now we have an extra rotation. Now we can use this as the input for our angle. What that will do is that additional rotation gave us that additional point that now we could use. So first thing is we'll go to a NURBS curve, plug all the components in. Now we'll be doing the same thing as we did with the treads up here. We'll be creating the vertical array. So I'll just copy this, use this curve as my input. And notice that now we have everything matching except for this first one. So what we need to do is take this first one and move it up by 1 tread. So we'll go to move this curve up in the Z direction by the tread height. So what we can do is now take our arrays, which are going to be vertical, and we will remove the initial one so we can replace it with the new, all of the vertical arrays. Or actually, we can do something a little bit more simple. We'll take the array and copy the now that we have it all put together like this, what we need to do is now create some points along those curves. We'll go here to divide curve. And now we can bring in a NURBS curve again. This will make sure that it's all put together into one, and we'll flatten the input. It will actually have to be a interpolated curve. What I'm seeing is that this line segment needs to go up. We'll do +1, 6 + 1. So hopefully you were able to see what I had to do there. What it was is that the line segments were not matching from beginning to end. And so now that they're matching, I can take them here as the output, join them, flatten the input, and so this is one continuous curve, which is exactly what I wanted to do. Now we can take this, hide this, and I'll have this available on my website so you can see if you did get stuck somewhere or if I confused you a little bit. So now that we have this flattened, then we can extrude or move down. So move this curve in the Z direction, but down. So I'll go to negative, and I'll go to 12, 12.5. We'll be doing the same thing, but up. But this time it's going to be the height. So 36 inches from that spot. Now we can loft inputs. And let's see what happens when we offset curve or offset surface. It's not working. One of the reasons is this crease here. There's a way to fix that. Once we have this line segment here, this line segment is made up of all of the points that are on the outside there. So what I need to do is divide curve, and we'll say 50. Then I'll interpolate this curve because now it's a seamless curve. And this is what we can move up and down. So override this and override this. So now we've created that railing on the outside. Now we're going to take this and offset it to the outside. So I'll go to offset surface. This time it will work. And we'll do 3.5. And now if we loft together these two surfaces, it creates a surface in between. Holding down shift, I add another one, and it creates, basically takes the lines, the outside lines, and lofts them together. Now we can join it into a B-rep. So all of these will get added using shift. Flatten the input, disable the preview, and we've created a solid outside. Now what happens is it's offset to the inside. So this is where we can switch that. And we will be doing the same thing to the inside set of points. So how do we do that? Well, we go back here where we rotated these points. We'll copy this again because we've already set the stage. We will, instead of using this start and end point, we'll be using this start and end point. We'll be using the start point. Then all of this gets copied down because we'll be using this as the input. and now vertical array like this. Same thing to the inside. This time it is offsetting correctly because we have offset to the outside. Oh, actually, no, this needs to be offset to the other side. So I override the negative into the positive. Railing width will be the same. So railing low. We'll call this railing base. Okay. The more numbers you use here, like the higher quality it's going to be. Like if I lower this even to a low number like this, you'll see that it starts eating into the inside. So if you leave it at a high number, it should be fine. It gets closer to the actual shape. And so with this, let's go back and look at what we've done here. In some portions, you'll see that I'll go a little bit quiet, and that's because I'm trying to figure out a few things at the same time. And so it's easier for me to just be a little quiet. But with that being said, hopefully you found this useful. Let's go back and look at all of our different sliders and see what we came up with. So starting with our inside diameter, this could also be like a wall that goes from the ground to the ceiling or to the roof. Stair width. A lot of the stuff that we preview, we don't necessarily have to look at, but it does help you understand how it was created. Go on to number of treads. Treads for landing. If you don't want any, you put 0. Although that creates a double one there. So you would have to actually do 1 because it will only be 1 tread for the landing. Then here we can increase it to whatever amount. Tread height. Pretty straightforward. Number of floors. Here we have the count. So this is the railing point count, railing base. This is how low it goes here. 6 will kind of match the treads. 36, 42. So that's the conclusion of the tutorial. Some of this stuff at the end got a little bit tricky, but as you can see, it's Nothing that is too crazy where you can't do it yourself. If you have any issues or anything, make sure to let me know in the comments below. I want to make sure to answer everything and get you guys going with this tutorial. If you want to get a hold of the script, I have my website, capettidavid.com. There I share the script, the model, and the video where you can, access the file and see how it was put together if you weren't able to achieve what I achieved. So thank you very much for being here. I post videos like these every week where you can learn parametric design. So thank you very much for being here, and I hope to see you on the next one.